Now, to do a question like this, normally what I'll do is I'll first A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, Q, R, S, T, U, V, W, X, Y, Z. Team Plank, thank you. Okay, then what I'll do is I'll put in my pointers, right? So here's S, right, and also a null character, all right? So S is pointing to that. If I can put a caret if you want to see it pointing. Okay, X is S plus 2. These are char stars, right? So that means there's X. And then Y is X plus 5. So 1, 2, 3, 4, 5. There's Y. Okay. All right, so now when I do stir copy X, 0, 1, 3, 4, 5, 6, 7, I can start here. There's X. That's what it's pointing to. So that's going to go 0, 0, 1, 2, 3, 4, 5, 6, 7, null character. Okay. I say stircat Y, A, B, C, D. Well, stircat is going to go find the null character, which is right here. Just what I put into X. Okay. And then I'm going to say, oh, sorry. And then I get the printf after the stir copy. So that's going to print S. So that's going to print A, B, 0, 1, 2, 3, 4, 5, 6, 7. Okay. Right. Because that's what it's like after the stircat. Or stir copy. Now I do stircat, so that's going to go to this. It's going to go to Y, find the closest null character, and then it's going to append the bytes here. So A, B, C, D, E, null character. So now here, when I print out X, it's going to print 0, 1, 2, 3, 4, 5, 6, 7, A, B, C, D, E. And then when I say print X plus 15, right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's going to print out the stuff starting at R. So R, S, T, U, V, W, X, Y, Z. Okay. We feel good? Did I get it right? I don't even know if I got it right. Let's see what the answers are. All right, good. That first one looked right. Okay. Now, all y'all who put in incorrect answers, make sure you understand why the correct answer is correct. As I said, guaranteed you're going to get a question that'll be of these kind of ilk. Yes, sir.
String copy as a null character?
Absolutely, yes. Always. And string in stircat, because it's got to end the string. Okay.
Does stir copy actually add a null character, or is it just taking it from the string literal?
Either way. I mean, really, they're both the same thing, really. So, yeah, I mean, yeah, sir, it's copying the null character, but it's also insert. It's kind of this. Either way you want to look at it. Okay, next one. Okay, the few, the proud. The people getting partial credit. Okay, and then the last one. Oh, there we go. Look at that. So I didn't stick a stray null character in there. All right. Just kill turning point. Why not? All right, now, let us suppose I want to read strings. I want to sort. I want to convert them. I want to do a two-way sort with them. Okay. I'm going to sort them as integers, but if they're duplicate integer values, then I'm going to want to sort them lexicographically. Okay? So, for example, let's suppose I have the following input. So here, let's get 30 random names here. Okay, and then okay, so now I've got 30 random strings, but I have random integers here. Let's randomize that. All right, and now I'm going to want to sort these again by integer first, and then by string second. Okay? I don't even like that. We're going to do something a little different. How much time do we got? We got plenty of time. I'm gonna assume, we're gonna do a different thing. I'm gonna assume that my input is in the form number, string. Any words, right? Because some of these can have 3 words in them. I think some of them can even have 1, but then none of them are here. Okay? So that's what I'm gonna do. Now here, I could do that just by sorting, right? because the spaces make it all work, that just sorting it as a string will work. But let's not do that. So here, let us, what should we do here? Let's go ahead and let's just do some random deletions here. There we go. There we go. All right. So now we just can't sort and have it work, right? So if I do sort, that's not going to work because the spaces get in the way. Okay. So what I'm going to do is I'm going to read these in. So here, let's get our program now. We can do this in 2 ways. All right. We can do this the hard way or the easier way. And let's also, we'll just do it that way. Oh, we can do some fun stuff in here. I'm just talking to myself. All right. So we're going to read everything in. I'll go ahead and create a tree. The first way I'm going to do this is using a comparison function. Okay? Ew. That's ugly. Maybe I won't use a comparison function. Sure, I'll use a comparison function. Why not? Let's create ourselves a struct. Okay, so here, struct, we'll call it person. And it's going to have an int being their number, and then a char star being their name. Okay. So first thing I got to do is read these into people. So while getLine is do the following. Am I going to error check? No, it's class. So I will now grab a person. So struct person star p. Here, let's get rid of that. Keep that. Okay. So p equals struct person star size of struct person. What is size of struct person? On a 4-byte machine, it's 8. What is it on an 8-byte machine? 16. Yeah, because it's going to add 4 bytes of padding after the number, because it's going to want to have the pointer be aligned. Okay. If I change the order, does it now become 12 or does it stay 16? Stays 16 because there's going to be 4 bytes of padding after the number, so that if you allocate an array of them, the name pointer is still aligned on an 8-byte quantity. Okay. Bless you. All right. So now we'll say p arrow number equals a to I is fields 0. Okay. It's missing p, isn't it? Thank you, Team Plank. I'm missing what now? Oh my God. Thank you. Team Dumbass. Yes. Thank you. That's not calling you dumbass. That's calling me a dumbass. Just so we're clear. Did I tell you what I swore in class when we first merged? Did I tell you about that one already? We merged. 2007. Computer science merged with electrical engineering. And computer engineers had to start taking my classes. And I swore in class, and I bitched about engineering because I was not happy that we had merged. And the student told the department head that I had sworn in class. So I had to get, that's how I met my new department head. That was how I met him. Was being called into his office to get yelled at for swearing in class. And he was like, I can't even believe I'm doing this. He's like, it's a dumb, but I have to. Bad, what's your name? And then the student also said that I hated all engineers and was worried I was going to be treating the engineers unfairly in the class. Nuts. Absolutely nuts. I love engineers, by the way. Actually, I love being in an ECS department now. I'm very happy, but computer engineers are freaking awesome. Yes, sir.
What is the struct underscore person? And then
an Alex Iso struct underscore person.
Typo. Team Plank, thank you. What else do we have? Is that wrong? No. Okay. Now, this one here. So, here's a trick. I'm going to teach you a trick with the Fields library. Are you allowed to use this trick? Absolutely. In the Fields library, you'll note there are two lines here, right? There's text 1 and text 2. Text 1 contains the line. The way the whole fields part of the Fields library works is I do a stir copy of text 1 to text 2. Then I go through and every white space character in text 2 I turn into a null character. And then I go through it again, and every time I get the first non-null character, that's where I set that pointer in Fields. So each pointer in Fields is actually a pointer to text 2. Now we can use that information to figure out where the first word starts, right? So I could do the following. I will do the following. Name equals stirdup is text 1 plus is fields 1 minus ix text 2. Right? Because, right, there's the pointer to the first word. There is the beginning of all of the pointers, so that distance is going to be the same distance as where that first letter is in text 1. Now it's also going to take the new line, which stinks, but life is what it is. Okay, so now what we can do is we can write a comparison, or we can insert this into the tree. So t equals new JRB. I can now say JRB insert gen t new jval v void star p. Okay, this is how you store generic data structures in anything. The dlist library is there's a field of the jval called v, which is a void star. All pointers are the same size, so this is a very legal operation, right? So now I'm going to take that, cast it to a void star, store it there. Okay. Yes, sir.
Do you need an opening curly bracket to the conf function?
I will. I'll get there. Thank you, though. I'm gonna write this first. Okay. Do I need to do anything here? No. So this can be new jval nothing. Okay. Now I need a comparison function. Do you think you should put part of your vows? I take you for better or for worse, and I will learn when your class is so that I won't call you during it. She hears everything. Okay, I didn't answer. One of y'all is going to tell her, right? She wants, her friend wants to come to one of my classes. 60-something-year-old woman. But then she also wants my wife to come. And she says if she is in my class and I point her out, she's going to make the open option that you all are allowed to say anything you want to her. Which is kind of powerful. But I mean, it's just be so tempting just to give her shit. That's the problem. It's so tempting. I mean, that's why you get married, right? So you can give each other shit. Am I going to get in trouble for that? Did I say anything wrong? Okay. I feel like I don't know anymore. Okay, comparison function. All right, so now I'm going to need to get a pointer here. Struct person star p. Okay, and I'm going to need P1 and P2 now. P1 and P2. Okay, now I'm giving, this is what I'm inserting. Okay, so I need to typecast these guys. So struct person star v1.v, right? Because that's the void star part. Okay, and now I'll compare numbers. So if P1 is less, P1 number is less than P2 number. If any of you are thinking Is it going to be a problem that your struct declaration is below there? And the answer is absolutely. Return -1 if it's greater. Is it as quick to copy and paste in in VS Code as what I just did? Can you do that as quickly in VS Code? Yeah? Do you get VI bindings in VS Code? Yeah? All right. Do you use them? No. Yes. Good. Okay. All right. Now, if they're equal, so now we'll say return strcomp p1 name, p2 name. Nice, easy comparison function. Okay. All right. I'm just letting you know right now, I wouldn't be writing this code. If I were writing a lab right now and not in class, I wouldn't write this like that. Right? I would do here. Printf name number name. Okay. All right. I mean, that's too much code to write before you test. You just got to test, right? So here, uh-oh. Damn, it sure looks like I have a bug, doesn't it? What's that? Oh, thank you, Will. If I had an extra piece of candy, I'd give it to you. Although you've already gotten 2 candies today. And you got the one you asked for. Good thing you found this bug. All right. It was never exiting, right? Because I just said while get line. In fact, if I had given it a blank line, it would have exited. Right? So this is why you test. Okay, there we go. Why am I getting an extra new line? Because the stupid person has a new line at the end of it. Drives you nuts. What do you think? Sterlen -1 and changing it to the null. I can't do it. Let's just eat the null character. All right, now I'm going to go ahead and insert. Now I got to traverse. Am I going to finish what I wanted to do today? Probably not. It's all right. You all are dying to watch that video, aren't you? You all watch it on high? Well, first off, you don't watch it, right? Unless you have to for lab or an exam, you won't watch the video. Second, you'll go through at what speed? 1.5? 2? Do I still talk at 2? Okay. Well, should I be a dick and talk real slow? Sorry. Printf. Okay, so now here, I need to go ahead and typecast the key back into a pointer of struct person. Temp key.s, and now printf %d %s with no new line, p number, p name. Okay. Oh. Thank you, compiler. Okay. Good. So let's do what I want. Now, this is not how I would do it. I'm just telling you, this is not how. If I were confronted with having to store in this way, I would not do it this way. This is how I would do it, and you all hate this. Okay, I'm just saying it right now. You all hate it. You hated it in CS302, and you hate it now, but you need to do it. Okay, and that is you need to create a multi-level data structure. And in here, what you're going to do is you're going to have a red-black tree whose keys are numbers and whose vowels are red-black trees. And in the second level red-black tree, the keys are going to be strings. And the vowel will be the person. Okay? So, we're going to go through here. We'll keep all this the same. Okay, get rid of that print statement. And now here what we're going to do is we're going to call find first to find the number and see if it's in the tree yet. So, temp equals JRB find int t p number. Okay. If it's there, we're cool. We got a pointer to it. If it's not, we need to insert the number into the tree, and its val needs to be a new, fresh red-black tree. So if temp equals null, temp equals JRB, insert int t p number new jval v void star make JRB. Okay? So I'm creating a red-black tree, putting it in as the val to this. It's also nice because this insert returns a pointer to what you just created. So that's nice because it saves you a step. In C++, that's a little more of a pain to do. Okay, so now when I'm here in the code, I know that temp is pointing to the node that has that number as a key and a red-black tree as a val. So here, let's call this T2. I'm going to do temp2 while I'm at it. And here, I'll say T2 equals JRB temp val.v. Okay? So I'm grabbing that second level red-black tree, and now I'm going to go ahead and insert the person into the red-black tree keyed on their name. So JRB insert stir T2 P name new jval v void star P. Okay, so the name is the key and the pointer to the struct is a val. Do I need to call stirdupe here? It's a good question. And I think a lot of you are often unconfident in your answer on this one. The answer is no. You don't have to insert. You don't have to call stirdupe. Why? I already did it here, right? I called stirdupe here, so my person struct has a nice permanent pointer to that string. So here I got them both. It's not going away. Now, if I went and deleted this person, well, first off, I delete the person. I've got to go through and delete the name because I called stirdupe. If I delete it and I didn't try to use the tree, the world will hurt, of course. That's going to be a disaster. All right, so now I got to do a nested traversal. Okay, so I'll do that, and now I'll say T2 equals JRB temp val.v, and now I'll do a second traversal. JRB traverse temp2 T2. Okay, I'll grab the person from the val now because the person's in the val, and now I can print out the. Okay. I go through this because you're going to have to do stuff like this. You're going to be using red-black trees and doubly linked lists in hierarchical data structures. Now maybe you'll pop them into a struct and it'll be a little cleaner, but you might just be doing what I do here, tree of trees. Okay? You just have to you got to get used to doing that and to doing that. And is it yucky? Yeah, of course it's yucky. Is it unsafe? Yeah, a little bit. But it's C. This is what you get in C. This is why people don't like C. Oh, nice. Did you see my bug before it was going to happen, Will? Oh, that shouldn't be a problem. That should be V. Oh, I see my problem. I see my problem. Copy paste will get you every time. Boy, that feels like that should have been like a segfault, doesn't it? I feel like I haven't. This is one of these things where I feel like I haven't fixed this bug. Oh, I have. Yay. Okay. It just seems weird. Like, why did I not get a segfault there? And the segfault should come. Oh. And because. So, all right. Think about it. When I did this, what was I getting the person from? I was getting them from that ones. So it's actually the tree. This was actually taking the tree and shoving it into a struct person. And maybe the first thing there was a legal pointer. God, what a horrible bug. Okay. All right. The lecture notes for red-black tree match kinda what I did. Okay, they go over all the same things. There's some of the programs are slightly different. That's fine. In that lecture, I go over a long program, which I've learned is not really a good use of class time because you all just sit there glazed out of your skull and don't want to do it. Okay, but I have a program in there that does a big data crunch. It has like 80 files of golf scores, and then it uses a red-black tree so that it's extracting each golfer and having it store in its own data structure. Then it has the tournaments have their own data structure, and then you want to sort the golfers, so you use a red-black tree to do that. So there's a lot of red-black tree stuff in there. So it's a good thing to go through if you are feeling like you need some more confidence with this. Of course, the other thing you can do is do your lab. Yep. Do it incrementally. Have I said that before? Program incrementally, especially this lab, especially when you got stuff with pointers and strings and your confidence level's not high with this stuff. Print, 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 print. As Dr. Schumann says, when in doubt, print it out. No, I think she says when in doubt, see out. But it's fine. It's all good. Just program incrementally. All right, I'll see you all in a week.